let's do this one right here. Okay, so sketch a graph of each polar equation. All right, remember that for letter A, it's going to be a rows. All right, and let me kind of ghetto with this. All right, so just the rows will be 1, 2. Let's go from here. You're just sketching it. 1, 2 here. I should have, you know what? Let me redo that one. One, 2 right here. And 1, 2 right here. So remember with the even function, you're going to have double the amount, okay, of petals. All right. For letter B, remember the A over B is less than 1. So when you do this, the A is 2, and it's on sign. So sign, remember, it's 1, 2, 1, 2. These are the x-intercepts right here. Then what it is, B minus A. So 4 minus 2 would be 1, 2 here. And then B plus A is 4 plus 2 would be 6. So 1, 2, 3, 4, 5, 6. So I'm going to mark the points in red. That way you kind of differentiate them. This is the inner loop right here. Okay, and then it should be this, this, and this right here. So again, number 7, you're just sketching it. You don't have to give me the table of values or anything like that. All right, cool. And it's plus. If it was minus, it would be reflected on the other side. I think we've done this already. All right. Number 8. I'll get the slope. Remember, if this is equal to each other. All right, so if they have the same magnitude and they have the same direction, all right, you're good. So that you get the slope with this one, and then you get the distance formula, or you can use the Pythagorean theorem. Okay, for that one. So it is, so the slope for this is up to, for this one, u, the slope of u is up to over 3, and the slope of v is up to over 3. Right, so we know that it has the same direction. They are parallel, right? Because again, if they have the same slope, they're parallel. And then you may want to do the Pythagorean theorem, 3 and 2. So it would be 3 squared plus 2 squared is equal to c squared, and 3 squared plus 2 squared is equal to c squared. And obviously they're equal to each other. So you can also do the distance formula. Well, let's finish this out. 9 plus 4 is equal to c squared. 9 plus 4 is equal to c squared. So they're both equal to the square root of 13. You could also get the points. So this is what, 0, 0. And this is what, 3, 2. So it would be 3 minus 0 squared plus 2 minus 0 squared. That comes out to 3 squared plus 2 squared, which is 9 plus 4, which is also radical 13. And then this is what? This is 1, 2, the R, and that is 4, 4. S is 4, 4. So you get the square root of, what is it, 4 minus 1 squared plus 4 minus 2 squared, which is 3 squared plus 2 squared, which is 9 plus 4, which is also radical 13. So we know that vectors are equal if they have the same direction and if they have the same magnitude. Magnitude, remember, is a distance. So we prove that right there. Okay, radical 13 is the magnitude. The slope tells us direction. Okay. Number 9. My number 9. Make sure I do this correctly. I'm hoping that these are really easy. I hope they are. I think they are. You're just going 3 of the rights, 1, 2, 3, and up 1, right? And you're just drawing this arrow right here. That's all you're doing. Okay, because remember, the I represents the x-axis, the J represents the y-axis. The number in front are the coordinates. So this is if you put it in component form, it's 3, 1. And then for a letter B, it's 1, -1, right? So it'll be, put it in blue, 1, -1. So that would be right here. And that's all you're doing. Draw it in 2 different graphs, just in case. That's all you're doing. Cool. For number 10 is pretty much graph -4, 4, 1, 2, 3, 4. This is the first point, 1, 2, 3, 4. 6, 2, 1, 2, 3, 4, 5, 6, 1, 2. And this is the vector that you're referring to. So how do you put that in terms of I and J? Remember, you're just going from, you're doing the X distance. So how many times are you going over here? And how many times are you going up? So in this case, you're going 10 to the right and up 6. So it would be V is equal to 10I plus 6J. Again, all this is easy. You just have to remember like how to do it, okay, and what they all refer to. Okay, so this shouldn't be too bad, right? Number 11. A lot of distributive property, 3, and then you put in the -3I plus 7J minus 4 times -I minus 6J. This will be what? -9I plus 21J. And distribute the minus sign. So it'll be plus 4I plus 24J. Combine like terms will be -5I plus 45J. And remember the component form is -5, 45. Right? So the unit vector is for number 13 is all you have to do is just get the magnitude first. So the magnitude would be 3 squared plus -2 squared. So that would be what? 9 plus 4, which is radical 13. So this is your magnitude. So just put that number underneath. It would be 3 over radical 13I minus 2 over radical 13J. Then rationalize it. So it'd be 3 radical 13 over 13 minus 2 radical 13 over 13, I and J. And that's your answer. The magnitude, yeah. And just put it underneath that's number 12. Number 13 is kind of the opposite. You already have the magnitude and you have the angle. And what you need to do is you need to find the vector in terms of I and J. So just keep in mind what this is. The magnitude is 6 right here. So that's 6. This is 30 degrees here. So you're pretty much, how do you get to this point right here? What is this vector here? What is this? I'll put it in blue. What is this right here? All right. So if you know this is a 30, 60, 90 triangle, this is going to be 3, and this is going to be 3 radical 3, right? So V is equal to 3 radical 3i plus 3j. Right, the 3 radical 3 represents the x value, the 3 represents the y value. Not too shabby, right? Look how fast we got through those. That was pretty good. All right. Now number 14 is limits here. Okay, let's kind of zoom in a little bit on these. Remember, here's -3, -3. I'm gonna put it as, I'm gonna put this red line at -3. So if we're coming from the left, because that's that minus sign, we're going this way. What's the limit on that? That is 2. Good job. If we're coming from the right and going left, going this way, it's also 2, right? If they're equal to each other, the limit of -3 as x goes to -3 is 2. The f of -3 is what? What do you think that one is? Undefined. Good job. Because there is no y value when x approaches -3 or x is -3. Okay. Letter E, let's go to 0 now. All right. As x approaches 0, so let me show, do that in green. Here's 0, so I'm gonna do it in green right here. Okay, from the left, you see that line or that arc? What's that equal to? What's E? What's the y value as x approaches 0? 0, good job. As x approaches 0 from the right, it's what? 3, good job. What's the limit as x approaches 0? D and E, good job. The f of 0 is what? Undefined. Okay. Last one. But here's 2. Here's 2 right here. From the left, what's our limit? From the right, what's our limit? What's the limit as x approaches 2? What's f of 2? We good? You getting this? Feel confident? All right, number 15. You'll get an equation where you have to make sure you know how to factor on that one, on this number 15. You're gonna have to factor. I'm gonna give you an equation where you have to cancel something out and factor. All right, and then so this is what? X minus 4, x plus 4, right? Over x plus 4. Cancel. So what are we doing? The limit as x approaches -4, you're just plugging it in, right, into this. What's -4 minus 4? Nope. You're down 4, then you go down another 4. -8. Okay, and that's that. Cool. So just make sure you're good, you're handy with the rational expressions. I'll probably, again, it's going to be a factorable expression. All right, so yeah. All right, now here's a table. As x approaches 5 from the right, notice that the plus sign is first. So we're going here and going this way. What would this be? -4. Good. As x approaches 5 coming from the left, what would that be? 4. What's the limit as x approaches 5? D and E. Good job. And then if I had the f of 5, what would that be? 18. I think all of you guys are ready for calculus. All right, here we go. Yeah. Because this is -4, this is 4, so they're two different numbers, right? On each side, coming from each side. So they're two different numbers, it's D and E. If they're the same number, it's that number. We good? All right. Recording.